In this video we have 5 problems to solve equations. Got some logarithmic equations, exponential, a mixture of exponential and log. So real quickly here, let's just go over some of the properties here. Property of exponentials. A to the x equal a to the y. Got the same base on both sides. X has to be y. Has to equal to y. Assuming that a is positive and not equal to 1. Property of exponentials there. Got some properties of logs here. You can pause the video as we go through here if you're not familiar with some of these. The definition of log over here, y is equal to log of x to base a. That means that x has to equal to a taken to the y power. Y of course represents the logarithm. Got your change of base formula. Okay, let's go to the problems now. So for the first one, we got natural log of e to the 5x equal to 15. Remember that the ln is the same thing as the log to base e. Log, if no base is given, it's understood to be base 10. So when you see ln, think of that as log to base e. So again, this is e. Property of logs, if this base here and this x and this base here, the base of the log and the given base here, e, they're the same. The answer is always what the exponent is. So the left side simplifies to 5x. On the right side I have 15. So now I have a regular linear equation, first degree equation, to solve for x. Divide by 5. 15 divided by 5 is 3. So the answer to this one is x equal to 3. You can easily check these by plugging back into the original equation and confirming that the left side and the right side are the same value. Now this one's a very basic one. You just got to use the basic definition of log. We have log of x to base 3 is equal to 4. By definition of log, that means that this expression here, or this value here, in this case it's x, is always going to be equal to this base, in this case 3, taken to that power. 4, of course, is the logarithm here. So the answer to this one is x equal to 3 to the 4th. 3 factors or 4 factors of 3 is 81. And number 3, basically the same type of problem, a little bit more involved because instead of just x, you have 5x minus 3. But again, by definition of log, that means that whatever this is, in this case 5x minus 3, has to equal to this base here, whatever it is, in this case it's 2, taken to that power, which is 5. Now it just becomes a regular first degree equation, linear equation. 2 to the 5th is 32. 5 factors of 2. Add 3 to both sides here. So that gives me then 5x has to equal to 35. 32 plus 3, 35. Divide both sides by 5 to isolate the x. And I get that x is equal to 35 divided by 5 is 7. Go to the next one then. We have e to the 2x plus 5 is equal to 8. So let's take the natural log of both sides here. Got natural log of e to the 2x plus 5 and natural log of 8. So I took the natural log of both sides. That's base e. Again, like earlier, this is e, the base here is e, and you got the exponential with base e. So let me put e just to make my point. If this base and this base and this base are the same, the answer is always the exponent. So this tells me then that the left side simplifies to the exponent, which is 2x plus 5. And that's equal to ln of 8. And we subtract 5 from both sides. So the 5's cancel out on the left side, so that gives me 2x is equal to ln of 8 minus 5. And we isolate the x by dividing both sides by 2. This cancels out. So we get x is equal to, so if they wanted an exact answer, it wasn't indicated here, you could give ln of 8 minus 5 divided by 2, and that's the exact answer. You want an approximation to this, then use your calculator, take the natural log of 8 minus 5 divided by 2, and that should come out to a minus 1 decimal 46. So here's the exact, and here's an approximate answer to 2 decimal places. And number 5 is one of the easiest once again. You got log of 3 to the x to base 3. The base of the log is 3, and the exponential has the base of 3. The answer is always the exponent. So x is equal to -1. Thanks for watching. We'll see you next time.